Imagine going to a fast food place and ordering food just by moving your hand. Hi guys, I'm Ava, and today we're going to build a project like this together. Imagine you walk into a fast food restaurant and without touching anything, just by showing your fingers you can select your food. For example, 1 finger means pizza, 2 fingers mean burger, 3 fingers mean sandwich. Then you just show a like sign, thumb up, and your order is placed. And the exciting part is, this is just the first part, and in the next part, we want to design a food delivery robot for it. So stay with me, because we are going to write this project line by line together and learn everything completely. First of all, we import the libraries we need. The CV2 library is used for image processing and working with the camera. The hand tracking from the cvzone library is used to detect hands and fingers. And the NumPy library is for matrices and imaging. We simplify its name by importing as NP. And time is for controlling time or intervals between events. And we also import the math library. Here we activate the camera so we can receive the live image. The number 0 means using the system's default webcam. Here we create a detector that only tracks one hand, because for now we are working with one hand, so we pass the number 1. Here we load an image as the background or food menu. You can create your own image, but if you want to use mine, I will put the image link on my GitHub. I will put the GitHub link down below. Now we resize it so later we can mark on it. This variable is called t and it's used for the ellipse angle. In fact, in our project, to show the food selection, we draw an ellipse around the food that gradually completes, for example, first a thin line, then a half circle, then a full ellipse. This t specifies that angle. For example, when t equals 20, it means 20 degrees out of 360 degrees of the ellipse is drawn. Each time the user shows the same food, t increases, and the ellipse gets bigger. This creates an effect like a selection animation, instead of suddenly appearing. This variable is the center of the ellipse, meaning the point around which the ellipse is drawn. But for now, it is 0 because no food is selected yet. This variable is the ellipse radii. An ellipse actually has 2 radii, one horizontal and one vertical. Here 0 means nothing is defined yet, but when food number 1 is selected, its value changes. We put this so we remember the last food the user selected. Why? Because we don't want the animation to start over each time the user shows the same food twice in a row. So with this variable, we understand whether the user chose the previous option again or a new one. If it's a new food, last chosen option is set to 0 and the animation starts over. A value of -1 means the program just started and no selection has been made yet. We take a list named fingers that shows the status of the hand's fingers. In this list, each finger is either 1 up or 0 down. For example, this list means 2 fingers are up. The function sums them up and the output is 2. We use this number to understand which food the user selected. 1 finger equals food number 1, 2 fingers equal food number 2, 3 fingers equal food number 3, only the thumb means like which is to place the order, a closed fist with no fingers up means reset the page. This simple function is the base of the selection detection in our project. What does this function do? Its name is clear__canvas. In our project, for showing the foods, we used an image named p1.png. Now whenever the user changes the selection or closes the fist, we need to clear all lines and marks. To do this, this function loads a fresh copy of the original image again. This function gradually increases the ellipse drawing angle so that when the user holds their finger, a nice animation appears around the food to show it has been selected. Now first, we enter a loop that keeps running as long as the program is open, continuously checking the camera image. In this line, a live frame is captured from the camera and stored in the variable img. The underscore sign means the first output isn't important to us, for example, whether the image was successfully taken or not, because we only want the image itself. Here we give the image to the findHands function to check if there is a hand in the image or not. This function from the cvzone library does two things at the same time. It detects hands and returns their info in the variable hands, like which fingers are up, hand coordinates, etc., and it updates the same image, drawing a box or marker around the hand to be visible in the output. Now that we have the image and detected hands, we resize the image to fit comfortably into the main menu or background image. Here the image is resized to 420 by 290 pixels. Now comes one of the most important parts of our project, detecting hand and finger movements. In this part, we want to see whether there is any hand in the image or not, and then check which fingers are up. Here we say, if only one hand is detected by the program, continue. The findHands function we used before may find multiple hands and return them in a list called hands. We are currently working with just one person and one hand, so this condition checks that if only one hand is found, continue. If no hand is found, or more than one, the rest of the code won't run. Now that we are sure we have one hand, we take that hand from the hands list. Lists start counting from 0, so hands\0 means the first detected hand. We put this into a new variable named hand1 to make it easier to work with. Now it's time to understand the state of that hand we got. This line uses the fingers up function to detect which fingers are up. The result it gives us is a list of 5 zeros or ones, each number corresponds to one of the fingers, from left to right, thumb, index, middle, ring, pinky. 1 means that finger is up. 0 means it is down. For example, this output list means only the index finger is up. Or for example, this output list means thumb and index fingers are up. Now we have a list of finger statuses. To understand how many fingers are up, we sum the list. For example, this list when summed results in 2, meaning 2 fingers are up now. We store this sum in a variable called fingersum to use later in conditions. For example, we say, if fingersum equals 2, then the user is selecting option 2. Now in the next part, we say, if the number of fingers up is 1 and the finger shape is not just the thumb finger up, which means it's not the like state, then this block of code runs. So this condition helps us distinguish different one-finger states from the like state. In the next part, we set the center coordinates and size of the ellipse to draw around the food. A1 is the ellipse center and A2 is the radii size. These values exactly determine which food the ellipse line is drawn around. Now we use the function we made before to clear the screen and reload the menu background image, so that every time a new state is selected, the page is clean and only the new food is outlined. Now we increase the value of t. This value is the angle used to draw the ellipse and causes the drawn line around the food to be shown as an animation, gradually completing. This ellipse is drawn around the selected food and it animates with the changing angle. Last chosen option is like a little reminder that the program keeps which food you last selected. This way, when you show the like sign and place the order, the program knows around which food to draw the like. Now, if the number of fingers up is 0, meaning the hand is clenched with no fingers up, we clear the screen and reload the menu background image so the page is clean and no selection is displayed. And we set the variable last chosen option to -1, meaning now no option is selected and the program knows the page is empty. And we write similar code for 2 fingers and 3 fingers like we did for 1 finger, with the difference that the dimensions are different and in the first condition for 1 finger, we don't need to exclude the thumb. This condition means only the thumb is up and the rest of the fingers are down. In this project, it means the user is showing the like sign. We clear the screen and reload the menu background so it is clean. We increase the variable t, which is for the animation of drawing the ellipse line around the food. We draw a green ellipse around the food. We set the angle to 400 so the ellipse is completely drawn and a full green line forms around the food, meaning the animation is finished. We draw a green ellipse around the food. We set the angle to 400 so the ellipse is completely drawn and a full green line forms around the food, meaning the animation is finished. This line means the live image we took from the camera means image is placed inside a part of the food menu background image P1. In other words, the user's own image is shown inside a specified frame on the screen, so both the menu and the user themselves can be seen. Here we open a window named Circle and show the final image means P1, which includes the menu and the user's image. This line acts like a timer that pauses the program for 1 millisecond, like the time.sleep command in other programs. This very short pause lets each frame image be properly displayed and allows the program to show new frames well. I would really appreciate it if you like this video to help grow my channel. And now we go to testing the video. And now we see that it works perfectly. Alright guys, this was my complete tutorial on our smart menu. If you watched carefully, now you can build a food selection system with your hand without any buttons. In the next video, we're going to complete this project and design a food delivery robot. Meaning the order placed with the like sign will now be delivered by a robot to the customer's table. If you enjoyed this tutorial, please like, comment, and subscribe because we're going to build a lot of cool projects together.